Hey guys, Miss Miranda here. So today's lesson is lesson 11.4 in the Go Math book, and we're going to be learning about polyhedrons. All right, polyhedrons are three-dimensional figures with faces that are polygons. So we're going to do a quick little review of what polygons are. So I'm going to take you back to lesson 11.1. So in order to really classify polyhedrons, we need to know how to identify polygons. All right, and in lesson 11.1, we learned that polygons were two-dimensional figures made up of straight sides, and those figures were always closed. Now, if we look here at this little chart where I have some shapes for you, we're going to identify some as polygons or not. All right, so let's go ahead and take a look at the heart. Would the heart be a polygon? If you said no, you are right. The heart is not a polygon. And again, I want to remind you that polygons are made up of straight sides. Does the heart have straight sides? No, it has these curves up here, right? So the heart is not a polygon. If I look at this shape right here, this shape is closed and it's made up of straight sides, right? So this is a polygon. How about the circle? Would the circle be considered a polygon? No, it has curves, right? Then we have a square, which is a quadrilateral, and we learned that the square was actually every type of quadrilateral. The square is a polygon. This triangle here would also be considered a polygon because it's made up of straight sides and the figure is closed. Moving on to this one here, this shape here has 1, 2, 3, 4, 5 sides. What type of polygon is that? Pentagon is right. Here we have a six-sided figure. That would be your hexagon, and of course that's a polygon. We have an eight-sided figure here, octagon. Then down here we have an oval. Would the oval be a polygon? The answer is no, because it has those curved sides. Down here in the middle we have the rectangle, and the rectangle of course is a polygon. And then we have the rhombus, which is also a polygon because it's made of straight sides. All right, so back to polyhedrons. Again, three-dimensional figures with faces that are polygons. Now, this word here, faces, what does that mean? Well, we're going to take a look at some three-dimensional figures, and I'm going to show you how you identify those faces next. All right, so before we start identifying polyhedrons, I want to go ahead and show you this three-dimensional figure I have here, and we're going to talk about three things. And those three things we're going to talk about are edges, vertices, and faces. All right, so we're going to identify how many edges, vertices, and faces this figure has here. And the faces for today's lesson is going to be the most important part, but I do want to go over this because this is something that you need to know. It's geometry, and it did come out in 4th grade math, so this is kind of like a little review. So if we look at my solid figure here, I want to first identify how many edges it has. If you see these nice sharp lines going around my figure, those nice sharp lines would be considered your edges. So I want to take a look at this figure and count how many edges it has. Well, if I look, this is a nice view of it. This is like a bird's eye view. So if I count the edges here, I see 1, 2, 3, 4, and then I'm going to obviously count these down here too. 5, 6, 7, and 8. So this solid figure here has a total of 8 edges. I'm going to go ahead and write that down. Vertices are the points at which those edges meet. So this point up here would be a vertex. This down here would also be a vertex. These are your vertices, the points where those edges meet. So if I count those points or those vertices, I have 1, 2, 3, 4, 5. So this figure here has 5 vertices. And then for today, the most important one is the faces, because when it comes to polyhedrons, knowing the name of the faces is very important because those names are going to be the names of the actual polyhedrons. All right, so if I look at this figure, I see quite a few triangles as faces. Your faces are going to be kind of like where you can rest the figure. It's going to be a flat surface where you can rest the figure. So I see 1, 2, 3, 4 triangles. And if I flip it, I see a square. So if I count those number of faces, again, 4 triangles, 1 square. It has 5 faces. And again, very important when it comes to identifying the faces, because that's going to help us out today to identify those polyhedrons. Next thing we're going to do is we are going to compare polyhedrons to 3-dimensional figures that are actually not polyhedrons. All right, so I have 2 pictures here of 3-dimensional shapes that are considered to be polyhedrons. Now, if you recall from the first picture that I showed you, polyhedrons are 3-dimensional figures with faces that are polygons. If you look at these figures that I put for you here, all of the faces are polygons. In this case here, this is a cube, right? If you look at the faces, all of the faces are squares. Squares are polygons. Therefore, a cube is a polyhedron. Down here, you have a pyramid whose faces are all polygons as well. The base of this pyramid is a square, and all the faces around it are triangles. Triangles and a square, all of those are polygons. Therefore, this pyramid here would be considered a polyhedron. Now I'm going to draw 3 shapes over here on the non-polyhedron side. And I want you to think, why are those shapes not polyhedrons? All right, so we got this first one here. And that would be considered a what? A cone. Good. Next, we have, let's see if you know what this one is. What shape would that be? When you have 2 circular bases, and then this is nice and smooth going around. That's right, cylinder. And then finally, we have this shape here. What shape, what 3-dimensional shape is that? If you said sphere, you're correct. All right, so I want you to look at these 3. Those 3 are not polyhedrons. Why do you think those 3 are not polyhedrons? All right, if you recall, polyhedrons, 3-dimensional figures with faces that are polygons. If I come over here, I see a couple of faces, right? There's a face here that's a circle. There's 2 faces here that are circles. And then your sphere doesn't really have any faces. But the reason these are not polyhedrons is because a circle is not a polygon. And the curves are not polygons. The moment you have curves in there, forget it. It is not going to be a polygon. It's not going to be a polyhedron. Because in order for it to be a polyhedron, it has to be not only 3-dimensional, but the faces have to be polygons. All right? Polyhedrons can be further broken down into 2 categories. So you have prisms and you have pyramids. So over here, the definition for prisms, it says a prism has 2 congruent polygons as bases and the lateral faces are all rectangles. So I'm going to show you an example of a prism. And if you look at this prism, again, it said it has 2 congruent polygons as bases. If I look at the very top of my prism here, that shape is a triangle. And if I look at the bottom, that is also a triangle. If I look around this polyhedron, if I look at these faces here, you see how they're all rectangles? All right, so this shape here would be considered a prism. Now, remember how I told you that it's very important to know the name of the faces because that's how you name these prisms? All right, so the 2 congruent polygons that are the bases of this prism would be your triangle, right? Because you have a triangle on top and you have a triangle on the bottom. So the name of this prism is going to come from those bases. So the bases are triangular, and this is a prism. So the name of this shape would be a triangular prism. You see that? Very important to know the shape or the polygon that's your base, because that's going to come, that's going to be the name of it. All right, now let's look at pyramids. So for pyramids, we have a pyramid has 1 polygon at the base and all the other faces are triangles that meet at a common vertex. So I'm going to bring a pyramid over here. Let's look at this pyramid. All right, so we have one polygon at the base. Look at the base. What shape is that? Yep, that's a square. So we have our base, and then all the other faces all around are going to be triangles. That's what's going to make this polyhedron a pyramid. And if you notice, all of those faces meet up here at one point. So when it comes to prisms, prisms have the same shape on the top and the same on the bottom. They don't really all meet at one vertex like the pyramid does. And that's very important. All right. So in order to name this pyramid here, I'm going to look at the base once again. So if I look at the base, the shape is a square. So my pyramid is going to be a square. That's right, pyramid, because this is a pyramid. So the name of the polyhedrons, whether it's a prism or a pyramid, the name comes from the shape of its base. All right. So what if you had, let's say, a square? If we had square faces, which this we know is a cube, but we can call it something else. We learned in the last lesson that a square is also a rectangle, right? So I can identify this cube as a rectangular prism as well. Why? Because I have a square on top, a square on the bottom. We have squares everywhere. All the faces are squares. And squares, I know, are also rectangles. So I can call this a rectangular prism. If I want, I can call it a square prism, or I can call it a cube. All right. Let's take a look at two examples here. What if I had this polygon here, which has 1, 2, 3, 4, 5 sides? I know that's a pentagon. And what if I draw lines that all meet at one vertex, just like that? What type of polyhedron would this be? Well, let's see. I know that the name of this is going to come from the base, and my base is a pentagon. So this right here is called pentagonal, and they all meet at one vertex. So it's going to be pentagonal pyramid. Why pyramid? Because the edges are meeting up at one common vertex. And I have all those lateral faces going around that are triangles. And then my polygon that is different is going to be my base, which in this case is a pentagon. And the name of the pyramid comes from the shape of that base. Let's try another. All right, so now we're going to start with this polygon here. And if I look at this one, I got 1, 2, 3, 4, 5, 6, 7, 8 sides. So this would be an octagon, right? So what if I drew another octagon up here and then connected the parts kind of like that? It looks pretty cool. All right, so I want you to picture this three-dimensional. You got an octagon in the bottom, you got an octagon on top. Now, would this be a pyramid or would it be a prism? I know that pyramids meet at a common vertex, and here there's no common vertex. I have the same base, I have the same bottom and the same top. They're both octagons. So this is a prism. Now, the name of this prism is going to come from that base. I need to know how to name that polygon in order to name this polyhedron. So my shape is an octagon, so this would be called octagonal prism. See that? So prism, same shape, same polygon on the bottom, same polygon on top. Pyramid, they're all gonna meet at one vertex. One more thing you're gonna see in the classwork today is going to be describing the faces of the polyhedrons and the non-polyhedrons. But basically, you need to identify, you need to be able to look at the polyhedron or the non-polyhedron, whatever the three-dimensional shape is. And you need to picture, okay, how would this look if I were to open it up? How would that look? So if I take a look at this picture here, and when I open it up like that, that's called a net. If I look at this picture, I see 1, 2, 3, 4, 5, 6 faces that are squares. If I were to put those faces together and kind of build a three-dimensional shape, would this be what turns out from this net? That looks pretty good. I think so. How about this one? If I were to put this together and kind of meet all these triangles up at the same vertex, would this create a cube, which we also learned can be called a rectangular prism? What would this build? That's right, a square pyramid. How about this one? I got 2 circular bases, and then I have this rectangle here in the middle. You need to picture that that rectangle is being rolled up, kind of like a paper towel roll. If I roll it up, this would be a cylinder. Good. So the net that matches this three-dimensional figure would be this net right over here. And I'm going to go ahead and circle it. Now, how about this one? If I had a cylinder, which of these 3 nets would be the one that belongs to this cylinder? So if I were to open up this cylinder, how would it look? Would this be it? No, this would make a cone, right? How about this one? That looks pretty good. And this? Ooh, what would this make? I know it's going to make a pyramid because it has all these triangles as lateral faces. But the name of this pyramid is going to come from that base. The base here is a hexagon. It has 6 sides, 6 angles. So the name of this pyramid would be hexagonal pyramid. So of course, that's not going to make this cylinder here. So the answer would be this middle net right here. Next one, I have a rectangular prism because I have both bases, the top and bottom are rectangles. So, and I know it's a prism because the vertices are not all meeting at the same point, right? Now, would this net make this rectangular prism here? I don't think so. I see triangles and I don't see any triangles here. So I don't think that's going to work. How about this? If I were to fold these pieces together, would this turn into a box? Possibly. And this? Oh, I see those triangles again. So this is going to make a pyramid. So here it is. This is the net that matches the rectangular prism. All right, the next one. Ooh, finally, I see a pyramid. So I'm going to be looking for those triangles all around for those faces. Is this going to work? Well, I see a square as the base and I see triangles all around. This looks pretty good right now. What would this make? Yep, this will make a cube. And this, I see 2 triangles and all the other faces are rectangles. So this would be a triangular, that's right, prism. So here's our answer for that one. This is the net that matches that pyramid. And then here, ooh, there's a triangular prism, huh? So we're gonna find which net works. And if you were listening in the previous one, we know that it would be this one here. You see that? Now, how about this net? What would this make? I see a hexagon here, and I see a hexagon here, and then all the other faces are rectangles. Hexagonal prism, good. And this, a square pyramid. So you see that? A net would be, how would those polyhedrons or non-polyhedrons, how would those 3-dimensional shapes look if I were to open them up? And if I were to open them up and then want to close them up, how would they look? So you can either go from here to the net, or maybe they will give you the net and you have to identify, okay, you know, this net would create what type of solid figure, what type of 3-dimensional shape can I make out of this? You need to be able to know that that would form a square prism, rectangular prism, cube. Remember, this has multiple names, all right? Last part here, let's go ahead and look at some examples of what you are going to see in the classwork today. So for the first one, it says classify the solid figure, write prism, pyramid, cone, cylinder, or sphere. If I look at this here, I know that that does not look like a sphere. It doesn't look like a cylinder, and it doesn't look like a cone. There's no curves in this whatsoever. Now, could it be a pyramid? Absolutely not. Because the pyramid, I know, has to meet all at the common vertex, right? And this has two congruent polygons. It has two triangles here. So this shape here is that's right, it's a prism. Now, if they just ask you to identify the shape as prism, pyramid, cone, cylinder, sphere, you can stop there. You don't have to call this a triangular prism. Some questions, they may go a little further and ask you what type of prism is it. Then you would have to say that it is a triangular prism. Why? Because it has the two congruent triangles as your bases. And then all the other lateral faces are rectangles. All right, let's take a look at this one here. It says name the solid figure. So now I want you to name that solid figure exactly what it's called. So I know that this is a pyramid because all of those edges are meeting at a common vertex up here. Where does the name of a pyramid come from? Yep, it comes from the shape of the base. This base here seems to be a square. So this is going to be called a square, what? Pyramid. See that? Square pyramid. All right, let's go ahead and take a look at this one down here. The figure below is a blank. So if I look at the base, I have a polygon with 1, 2, 3, 4, 5, 6 sides. I have the same polygon on top. I know that if I have a polygon as the base and a polygon on top, I know that that's going to be a prism. But what type of prism is this? That's right. The name of this prism is going to come from its base. Its base is a hexagon. So this is hexagonal prism. And remember, prisms are going to have those lateral faces all around that are going to be rectangles. Last one here, describe the faces of the prism below. All right, so they're telling us it's a prism. We know that. We have 1, 2, 3, 4, 5 sides for this polygon here, and we have the same polygon on top. This polygon is a pentagon. So we have 2 pentagons. I'm going to write that here because I'm describing the faces. 2 pentagons. And then what are all the lateral faces that go around? Yep, they're rectangles. How many rectangles? 1, 2, 3, 4, 5. 5 rectangles. You see that? Easy peasy, right? Can't wait to see how you guys do in today's lesson. Have fun! Toodaloo! Woo!